Welcome to Chapter 4, where we will begin to look at rational expressions or fractions that contain polynomials. Now, I know that this seems like a large jump from our previous lessons, but in reality, not only are they not difficult at all, but they're extremely common in the later mathematics and physics. This first lesson of Chapter 4, we will look at what makes an expression rational and how to simplify them into a much more readable form. We will then use the techniques of polynomial operations to simplify them. Now, what exactly is a rational expression? A rational expression is a fraction that has a polynomial in its numerator, denominator, or both. For example, x plus 1 divided by 2, 3 divided by x squared minus 6x plus 9, and x plus 1 divided by x squared minus 1 are some basic rational expressions. The first one has a binomial in the numerator. The second expression has a trinomial in the denominator. The third expression has a binomial in both the numerator and the denominator. These are all examples of rational expressions. There's also no limit to how we may encounter these types of expressions. For example, sometimes you may find them squared or even under square roots. Before that, however, I want us to look at how we can simplify these types of expressions. The easiest way of simplifying them is to look for factored terms that can cancel each other out. This in particular is actually an application of the inverse property of multiplication. If a number, or in our case, a term or even a polynomial, is multiplied by its inverse, such as x plus 1 times 1 divided by x plus 1, this equals x plus 1 divided by x plus 1. Then the product is equal to 1. This is the most common method to simplify a rational expression. So let's go ahead and work out some examples so that we can learn to simplify these with ease. Number 1, 5x squared minus 10 all divided by 5. Our first example has a polynomial in its numerator only. Looking at our binomial, it has a GCF that we can factor out. 5 times x squared minus 2 divided by 5. Since the 5 has to be fully factored out of the numerator, we can use the inverse property of multiplication and simplify our rational expression one step further, leaving us with x squared minus 2. Number 2, x squared minus 4 divided by x plus 2. Here we have a binomial in both the numerator and denominator. While it seems nothing can be done with the denominator, notice that the numerator is a difference of perfect squares. We happen to know a special formula to help us factor that. X minus 2 times x plus 2 divided by x plus 2. If we take the freedom to put parentheses around our denominator, we can see that x plus 2 divides out to 1, leaving us with x minus 2. Number 3, 2x squared minus 8 divided by 2 times x plus 2. This rational expression has an unfactored binomial in the numerator and a factored binomial in the denominator. First, we can factor out the GCF of the numerator and then simplify. 2 times x squared minus 4 divided by 2 times x plus 2. This equals x squared minus 4 divided by x plus 2. Check that out. We ended up with the same rational expression from number 2. We already have the answer, x minus 2. Number 4, 2x squared minus 5x plus 3 divided by 2x minus 3. Now we're getting somewhere. We have a trinomial in the numerator and a binomial in the denominator. Let's determine if we can factor the numerator by using the factorization theorem. b squared minus 4ac. This gives us negative 5 squared minus 4 times 2 times 3, which equals 25 minus 4 times 6, which equals 25 minus 24, which equals 1. Since 1 is a perfect square, that is, the square root of 1 equals 1, we can factor this using known methods. The factors of 2 times 3 equals 6 that sum up to negative 5 are negative 2 and negative 3. So our numerator becomes 2x squared minus 2x minus 3x plus 3 divided by 2x minus 3. Using grouping, we have 2x times x minus 1 minus 3 times x minus 1 divided by 2x minus 3. This will leave us with x minus 1 times 2x minus 3 divided by 2x minus 3, which equals x minus 1. Number 5, x plus 3 squared divided by x squared plus 6x plus 9. Our rational expressions have been steadily getting more difficult. We now have to factor both the numerator and the denominator. Starting with the numerator, we see we have a squared binomial. We know the rules for those, so we can factor it out as x squared plus 2 times 3x plus 3 squared divided by x squared plus 6x plus 9, which equals x squared plus 6x plus 9 divided by x squared plus 6x plus 9, which equals 1. Knowing how to simplify and work with rational expressions allows us to excel in our study of algebra. There are many applications that involve polynomial expressions that are or become rational. Just as in the last chapter, where we learned to perform operations on polynomials, this chapter will be much the same. In the next lessons, we'll look at what can be done to multiply, divide, and add rational expressions. You'll find that they'll follow the same rules as when performing operations on rational numbers.